What if you could increase the throughput, reduce pressure loss, or increase the heat recovery in your preheat exchangers? What if you can reduce energy costs and associated NOx emissions by decreasing the fuel gas burned in the downstream fired heaters? What if you could do all this without hiring outside engineering resources, without changing piping or modifying existing foundations, and without extended downtime? Twisted tube heat exchanger technology is the solution. Metalforms Heat Transfer has engineered the twisted tube heat exchanger bundles to enable you to attain your process objectives with a plug-and-play solution by simply replacing a conventional tube bundle with a twisted tube bundle custom engineered to fit in the existing heat exchanger shell. Metalforms can help you achieve your environmental stewardship or ESG goals by reducing emissions while boosting profitability. Common applications for twisted tube bundles where our customers are reaping these benefits include crude oil preheat trains, feed effluent heat exchangers, overhead condensers and reboilers, and crude distillation reforming and hydrotreating units. How are twisted tube bundles different from conventional tube bundles? Metalforms heat transfer starts with a normal tube and creates a twisted tube through a cold forming process. When these tubes are grouped together, they form a triangular tube pattern as opposed to the square tube pattern found in many conventional tube bundles. The triangular tube geometry allows for a baffle-free design as the tubes are self-supporting, a cleanable triangular pitch with multiple cleaning lanes. A compact tube bundle that allows more tubes in a single shell than conventional round tubes. And an optional E to F conversion allowing a more efficient 2-pass F bundle inside an existing single-pass E shell. The benefits you can achieve using twisted tube bundles include minimized damaging flow induced vibration, the potential to mitigate fouling, an increase in heat recovery and reduced pressure drops, and the potential for higher flow rates. Due to the generally longitudinal flow pattern of the shell side fluid and the multi-point support structure of the bundle, the potential for flow-induced damaging vibration is mitigated. The exclusion of shell side baffles eliminates dead spots where sediment can accumulate and cover heat transfer surface area. The swirl flow on the tube side increases the shear velocity, ultimately decreasing the fluid boundary layer. Increasing the tube side heat transfer coefficient can provide increased heat transfer based on the application. The longitudinal flow allows for a lower relative pressure drop when compared to segmental baffle designs. This can also allow for a higher throughput at the same pressure drop based on the application. Contact us for a free evaluation to see how twisted tube heat exchanger technology can help you reach your environmental stewardship goals through reduced emissions and increased energy efficiency and profitability.